in the stillness of the cosmic void, where silence stretches beyond imagination and eternity hums beneath the faint whisper of ancient starlight, there exists a rule so absolute that it defines the very meaning of motion, of existence, of time itself. The speed of light, 300,000 kilometers per second, is more than a number. It is a cosmic covenant, an invisible line woven into the very threads of space-time, setting the rhythm to which the entire universe moves. Every beam that escapes a distant sun, every reflection on the oceans of Earth, every glimpse of the night sky, all are echoes of this singular, relentless velocity. It is light that binds the cosmos together, not by chains, but by the geometry of reality itself. Across the endless darkness, photons race between galaxies, carrying the past toward the present. The light from ancient stars, long dead, long gone, still crosses the interstellar sea, arriving at our eyes as fragile ghosts of what once was. In that moment, we do not see the universe as it is, but as it was. Every glance toward the sky is a journey backward through time. The universe, in its quiet brilliance, has hidden its truth within the constant of light, that nothing, not even thought or dream, can surpass its pace. Yet, the human mind is a restless thing. It was never content to obey the limits written into nature. From the earliest sparks of discovery to the colossal engines of modern science, humanity has sought to chase the light itself, to catch the horizon and see what lies beyond. But light speed is not merely fast, it is final. As an object accelerates, its mass grows heavier, its time slows, its very essence bends under the burden of its own motion. The closer one moves toward light speed, the more the universe resists, as though defending its deepest secret. Einstein was the first to see the pattern, that light's constancy was not a quirk of measurement, but the foundation of everything. No matter who observes it, no matter how fast one moves, light remains unshaken. It is the silent guardian of cosmic order. Through it, time and space are bound in a single fabric, inseparable and eternal. And yet, within that unbreakable beauty lies a paradox. If light defines the structure of the universe, then to reach its speed would mean to step outside of existence itself, to move beyond time, beyond matter, beyond what reality can contain. The stars shimmer across the endless black, their brilliance both invitation and warning. Humanity gazes upward, haunted by a question it cannot silence, a question as old as curiosity itself and as dangerous as truth. What would happen if we ever reached the speed of light? In the age before electricity, before the hum of machines or the whisper of radio waves, there was only light, mysterious, intangible, and impossibly fast. It flickered in candle flames and shimmered through raindrops, a silent messenger that bridged the heavens and the earth for centuries. It was thought to be instantaneous, a divine pulse that connected all things at once. But in 1676, a Danish astronomer named Oerakma, while studying the eclipses of Jupiter's moon Io, noticed something strange. The timing of those eclipses shifted depending on Earth's position in its orbit. Light, he realized, did not arrive instantly. It took time to travel across space. In that subtle delay, just a few minutes of difference, humanity first glimpsed the finite nature of illumination, the first trace of a cosmic limit that would haunt science for centuries. As telescopes sharpened and instruments improved, the speed of light became more than a curiosity. It became a number. From the mirrors of Fizeau and Foucault to the precision of Michelson's rotating apparatus, light's velocity was captured, measured, refined, a constant of unimaginable magnitude, roughly 300,000 kilometers every second. To human senses, it was inconceivable. In the time it takes to blink, light could circle the Earth 7 times. Yet within this speed hid something deeper, something that would one day rewrite the laws of reality. In 1905, a young patent clerk named Albert Einstein published a paper that would shatter the comfortable order of physics. The speed of light, he proposed, is the same for every observer, no matter how fast one moves, no matter the direction or distance. The universe bends itself to protect this rule. If a traveler rushes forward, space stretches and time slows to preserve light's constancy. The universe, in a sense, conspires to keep light unchanged. Einstein's revelation was both simple and devastating. The flow of time and the measure of distance were not fixed. They were elastic, molded by motion and gravity into a single, seamless continuum. Space CETIME. To understand this is to glimpse the strange machinery of reality. Imagine a clock aboard a ship traveling near the speed of light. Its hands turn slower, its seconds stretch into eternities. A ruler carried aboard that ship shrinks, its length compressed by its motion. To those within, nothing seems different. To those outside, the world distorts like a dream bending at the edges. It is not illusion, it is the true nature of the cosmos revealed when pushed to its limits. Time and space are not separate entities, but 2 faces of the same vast fabric, twisting to obey the one unbreakable commandment. Light speed must remain constant. Modern science has tested this truth again and again, and every experiment has bowed to its authority. In 1971, atomic clocks flown aboard commercial aircraft proved time dilation was real. The moving clocks ticked slower than those on the ground, by mere billionths of a second, yet enough to confirm Einstein's vision. In the tunnels of CERN, particles hurled to near light speeds gain mass and age slower than their stationary counterparts. Even the satellites orbiting Earth must account for these distortions. GPS systems, guiding every aircraft and ship across the planet, rely on corrections born of relativity. Without them, navigation would fail within hours. Every digital map, every path traced across oceans and skies, exists only because the universe bends itself to the will of light. It is a humbling thought that something so familiar, so constant, is also the foundation of existence itself. Light is not merely what allows us to see. It is what allows reality to be. It dictates how fast time flows, how space stretches, how matter moves. It is the heartbeat of the cosmos, the rhythm by which everything else keeps time. Every photon that strikes the human eye carries within it the same immutable speed that has defined the universe since its birth. And as those beams travel, unwavering, across billions of years and trillions of kilometers, they whisper the same truth to every observer in every corner of the cosmos. You may change, you may move, you may even age and die, but light remains eternal, unbroken and absolute. Time, the quiet companion of every heartbeat and every orbit, is not what it seems. To most, it flows like a river, steady, unbroken, predictable. Seconds become minutes, minutes become hours, and from those hours rise the stories of stars and civilizations alike. Yet beneath that familiar rhythm lies a truth far more unsettling. Time is not universal. It bends, it stretches, it warps, and under the immense strain of motion, it begins to break. The faster something moves, the more reluctant time becomes to carry it forward. Near the speed of light, seconds stretch into centuries, and eternity itself begins to stall. This strange phenomenon, known as time dilation, is one of the most haunting implications of Einstein's relativity. It tells us that motion and time are not independent, that velocity and existence are entwined. In the cosmic ballet of matter and energy, to move quickly is to slow one's own clock. To approach light speed is to slip out of rhythm with the rest of the universe. It is not fantasy, it is measurable, tested, and proven by the very particles that streak through the upper atmosphere each day. High above Earth, in the thin veil of air that shields our planet, cosmic rays strike atomic nuclei, creating subatomic particles known as mu. These particles live brief lives, fractions of microseconds, so fleeting that they should vanish long before reaching the ground. Yet they do reach it. Their internal clocks tick slower because they are moving near light speed. To them, only an instant has passed. To Earth, they have lived lifetimes longer than nature intended. The laws of physics have not been broken. Time itself has stretched to accommodate their motion. The same truth follows the astronauts who drift beyond Earth's gravity. To those on the ground, a few months pass. To those in orbit, time flows slightly slower. The difference may be milliseconds, but it is real, etched into atomic clocks that measure the passing of each vibration of cesium atoms. These tiny discrepancies are not merely curiosities, they are echoes of a universe that refuses to move in unison. When one moves, even by a fraction of light speed, the fabric of time adjusts itself, ensuring that light remains the eternal yardstick. Imagine a clock aboard a ship accelerating through the void. As its engines roar, the hands of that clock begin to lag behind their counterparts on Earth. The seconds stretch like elastic bands, pulled tighter and tighter as the ship draws closer to the cosmic limit. If one could see it from afar, it would appear frozen, suspended in a silent protest against the speed it endures. To the traveler within, nothing feels different. Their heart beats, their thoughts unfold, their moments seem unchanged, yet outside, the universe watches as their time falls behind. The paradox grows deeper. What happens at the ultimate threshold? The speed of light itself. According to relativity, a photon experiences no time at all, from its birth in the heart of a star to its death in a human eye. It crosses billions of light years without ever aging a moment. For light, distance, and duration collapse into a single, eternal now. It exists outside the flow of time, neither past nor future, but a perpetual instant. It is a state no object with mass can ever achieve, for to do so would require infinite energy, the impossible price of perfection. And so the question arises, is light timeless because it moves perfectly? Or does perfection demand the death of time? Perhaps time itself is the shadow cast by imperfection, the toll paid for existing below the threshold of the absolute. To move through time is to fall short of eternity, to exist in a realm of consequence and decay. Light, in its endless speed, escapes that realm entirely, unaging, unbound, indifferent. It is the only thing that truly moves without moving, seeing all points of its journey as one dot. As humanity gazes toward this sacred velocity, the laws that once seemed firm begin to twist. Time, once linear and obedient, becomes fragile. The universe, once a steady clockwork, reveals itself as a living fabric of motion and memory. Each step closer to light speed peels away another layer of reality's illusion, showing that the greatest boundary in physics may not be speed, but time itself, the cosmic current that resists our ascent toward eternity. Yet the deeper one looks into the nature of time under strain, the more the boundaries between science and philosophy begin to blur. Time dilation is not merely a mechanical effect. It is a window into the architecture of existence. In the realm of relativity, time and space are not passive backgrounds upon which events unfold. They are dynamic participants, reshaping themselves to preserve the balance of motion and light. Every moment, every distance, every heartbeat adjusts in subtle obedience to this universal order. When an object moves faster, its passage through space consumes more of its total motion, leaving less for its journey through time. The traveler who races through the cosmos does not simply move across distance. They trade their time to do so. Motion becomes an exchange, a silent bargain between existence and duration. In laboratories, the proof emerges again and again. Inside the particle accelerators of CERN, protons are flung to velocities so close to light speed that their lifespans stretch far beyond what they would be at rest. They live longer, not because of energy or shielding, but because the universe itself bends to let them endure. In those infinitesimal fractions of a second, the particles reveal a truth the human mind struggles to grasp, that time is not absolute, but deeply personal. Every observer carries a different tempo of existence, shaped by their motion and their gravity. The faster they move, the slower their inner clock ticks. It is a truth as elegant as it is unnerving. The universe does not tick in unison. It hums in countless overlapping rhythms, each one real, each one true. This revelation alters more than science. It redefines the meaning of life and memory. On a planet that spins and orbits within a cosmic web of motion, time is already relative. The head of a mountain experiences it slightly faster than the depths of the sea. The seconds in the heart of a black hole stretch toward infinity, while those far from its pull race ahead. In the grand scale of the cosmos, time flows like a river filled with eddies and currents, never uniform, always reshaping. The human desire to measure it, to trap it in seconds and hours, is an act of defiance against a truth too vast for simple comprehension. If one could somehow watch the universe from beyond its fabric, from a realm untouched by light or motion, time itself might appear not as a line, but as a landscape. Every moment, past and future, would exist simultaneously, frozen in the geometry of space-time. What the human mind perceives as now would be nothing more than the path consciousness takes across that landscape, one slice at a time. In this view, the flow of time is not universal motion, but local perception. The universe does not change. The observer does. And as motion bends and time slows, the observer's path through that eternal landscape warps with it, creating the illusion of dilation, of delay, of endurance. Approaching light speed would mean slipping sideways through this timeless terrain, where each moment stretches wider and wider until duration itself dissolves. The traveler nearing that threshold would not merely move faster, they would drift towards stillness, frozen in the eyes of the universe, caught between existence and non-existence. The stars ahead would blue shift into blinding fire, while those behind would fade into crimson echoes. Space would tunnel inward, a corridor of collapsing distances, and time would fade into silence. For those left behind, centuries might pass. For the traveler, perhaps only an instant. And at the unattainable limit, light speed itself, even that instant would vanish. There, at the edge of the possible, lies the universe's deepest enigma. Time, it seems, is not destroyed at light speed. It becomes irrelevant. Perception, movement, sequence, all dissolve into the absolute symmetry of light. To be light is to be everywhere at once, to cross eternity in zero time, to exist as both journey and destination. It is the perfect motion that erases the need for change. But that perfection carries a cost. To reach it, one must surrender mass, identity, and the very experience of becoming. No traveler could witness such a state, for witnessing requires time, and time cannot exist at the speed of light. Thus, the pursuit of light speed becomes a mirror, held up to existence itself. It reveals that the human longing to conquer time is also a longing to escape imperfection, to transcend the limits that make life possible. Every dream of surpassing light is, at its core, a dream of timelessness, a return to a state beyond decay and loss. Yet in that pursuit lies the paradox of all creation. Without time, there can be no change, no growth, no life. The speed of light stands as both the universe's gate and its guardian, reminding all who look toward it that eternity is not meant to be reached, only understood. And as humanity inches closer to this luminous boundary, it does not defy nature, it deepens its dialogue with it, uncovering, piece by piece, the sacred geometry of time itself. The dawn of the 20th century carried with it a quiet turbulence, a scientific world shrouded in uncertainty. The great minds of the 1800s had mapped the heavens, mastered the laws of motion, and bottled electricity into the veins of civilization. Yet something in the fabric of understanding was fraying. Light, the purest, most ancient signal of the cosmos, refused to obey the rules. It rippled like a wave, yet struck like a particle. It seemed to travel through nothing, yet required a medium by every known law of physics. To resolve the paradox, scientists invented the luminiferous ether, an invisible ocean that filled all space through which light could sail. But when the Michelson-Morley experiment in 1887 sought to measure the Earth's motion through that ether, the result was silence, a null result, as though the ether did not exist at all. It was a wound to classical physics, one that deepened with every attempt to explain it. Amid this confusion, in the stillness of a small patent office in Bern, Switzerland, a young clerk with unassuming eyes wrestled with the question that had eluded the greatest scientific empires. Albert Einstein, a man without a laboratory, without academic rank, but with an imagination that reached beyond the walls of tradition, began to wonder, what if the problem was not with light, but with the assumptions surrounding it? What if light did not need a medium because it was the medium, the constant against which all motion was measured? In 1905, he wrote a paper that would fracture the universe open, on the electrodynamics of moving bodies. Within its quiet pages lay a revolution so deep that it would rewrite the language of reality itself. Einstein's insight was not born of experiment, but of pure thought. He imagined a simple yet impossible scenario. What would happen if one could chase a beam of light? As the mind accelerated closer and closer to that beam, logic itself began to distort. If the observer ever caught up, the light would appear frozen, but that would contradict every observation, every equation. The only way to preserve the laws of nature was to allow time and space themselves to shift. Distance could no longer be absolute. Duration could no longer be fixed. The faster something moved, the more space contracted, and the more time slowed, until at light speed, both distance and time dissolved entirely. From this realization emerged the special theory of relativity, a new foundation where the universe was no longer a stage, but an active participant. Motion was relative, but the speed of light was not. It was the anchor of reality, the single unbreakable law threading through all perspectives. The universe, Einstein declared, would bend itself to ensure that light's velocity, 299,792 kilometers per second, remained constant. Time would stretch, space would warp, mass would shift, but light would not yield. The universe would protect that constancy as though it were the heartbeat of creation itself. This new order of thought ignited one of the most profound conceptual awakenings in human history. It dismantled Newton's clockwork cosmos and replaced it with something fluid, alive, and intertwined space-time, a four-dimensional fabric where energy and matter sculpted the geometry of existence. For the first time, mass was no longer a passive weight. It was frozen energy, potential condensed into substance. And from that realization came the equation that would echo through every corner of science. E equals mc. Energy and mass were not separate domains, but mirror images of one another, their unity bound by the constant speed of light. The universe was revealed as a vast interplay of transformation, where matter could ignite into pure energy and energy could condense back into matter, a cosmic dance, governed by light itself. Yet within that simple equation lurked a paradox as haunting as it was profound. If energy and mass were equivalent, then to accelerate a mass closer to light speed meant feeding it more and more energy. But each infusion of energy increased its mass, making further acceleration even harder. The closer it came to the speed of light, the heavier it became, until the energy required to push it further approached infinity. In this elegant impossibility lay the universe's ultimate safeguard. Nothing with mass could ever reach light speed, for doing so would demand infinite energy, and infinity does not exist in the realm of the finite. The universe, in its quiet perfection, had drawn a boundary not through force, but through balance. Einstein's revelation was not merely a scientific triumph, it was a philosophical awakening. It whispered that the universe was not built of absolutes, but of relationships. Time was not a river flowing independently. It was shaped by motion, by gravity, by the very act of existence. The cosmos was not cold and mechanical, but responsive, elastic, and self-consistent. Through Einstein's vision, humanity glimpsed a deeper truth, that reality itself was a negotiation between energy, matter, and light, an eternal conversation encoded in the geometry of space-time, in the quiet after the storm of discovery. One could almost sense the universe exhaling. The mysteries of motion and mass had found harmony, but the implications reached far beyond the chalkboards of physicists. If mass and energy were one, then stars, planets, and people were all woven from the same luminous fabric that filled the void. The light of the sun, the heat of a star's core, the spark within the human mind, all were manifestations of the same equation, expressions of the same fundamental truth. Light was not just a traveler through the cosmos, it was the cosmos, translated into motion, and yet, for all its beauty, Einstein's revelation opened more questions than it closed. If energy and mass were two faces of the same coin, what would happen if one side could be pushed to its extreme? What if mass were given infinite energy? What would the universe do to protect its balance then? In the quiet hum of the cosmos, the laws of relativity held their silence. The answer, perhaps, lay not in the mathematics, but in the very architecture of space-time itself, where gravity, time, and light would soon converge into the next great mystery. The world after 1905 would never see light the same way again. What had once been a gentle illumination, a tool for vision and warmth, became the very blueprint of existence. Light was no longer just what revealed the world, it was what defined it. The physicists who followed Einstein began to realize that every equation, every law of motion, every particle interaction whispered the same truth. The speed of light was not a property of light alone. It was the skeleton key to space-time, the fixed pulse that synchronized all of creation. From that moment on, every journey into the unknown, from quantum mechanics to cosmology, would orbit around this single, unwavering constant. But beyond the blackboards and laboratories, there was something deeper, almost sacred, in what Einstein had uncovered. In the human imagination, light had always been the symbol of knowledge, purity, revelation. Across centuries, from the candles of ancient scholars to the telescopes of modern astronomers, Light had guided the search for truth. Now science had revealed that this metaphor was no coincidence. Light was truth itself, not in a poetic sense, but in the literal fabric of reality. Every observation, every act of seeing depended on it. To measure time, to perceive distance, to define causality, all relied upon this universal constant that no being could outrun or surpass. It was as if the universe had chosen light to be its eternal speed limit, ensuring that all experience, no matter how vast, would remain connected through one cosmic rhythm. The implications spread like wildfire through every field of thought. Philosophers and scientists alike began to wrestle with the consequences of relativity, not only what it meant for physics, but what it meant for existence itself. If time could stretch and space could bend, then what was reality? Was it an independent structure or a dynamic illusion shaped by perspective? Einstein had revealed that there was no single now, that every observer carried their own slice of time, moving through a universe where simultaneity itself dissolved. The idea was dizzying, almost unbearable in its depth. Reality was no longer a single, absolute stage. It was a web of infinite presence, each woven by motion and light, and yet, through all the abstraction, Einstein himself remained grounded in simplicity. He once said that the secret of creativity was to never stop questioning, and that the most beautiful thing one could experience was the mysterious. Perhaps that is what defined his revolution, the willingness to embrace mystery, not as an obstacle, but as an invitation. In that sense, his theory was more than physics. It was a philosophy of humility before the cosmos. It taught that nature's laws were not to be conquered, but understood, that boundaries were not barriers, but structures of meaning. The speed of light was not a wall meant to cage the human spirit. It was a mirror reflecting the limits of perception, showing that truth lies not in defiance of nature, but in harmony with it. As decades passed, the evidence only deepened the revelation. From the curvature of starlight during eclipses to the precision of atomic clocks orbiting the Earth, every test confirmed Einstein's vision. The cosmos had been rewritten, a vast continuum of energy and matter, bending under the influence of speed and gravity. Humanity had discovered not only how the universe worked, but also how delicately it was tuned, how every moment and motion conspired to preserve the sacred balance that light defined. And so, as the scientific world stood in awe of this new understanding, a quiet realization began to settle. If this speed, this constant of creation governed everything, then to reach it would be to touch the very foundation of existence. What would it mean to break that boundary, to become light itself? Could a being cross that horizon and survive, or would the universe unravel to protect its order? Somewhere between curiosity and reverence, between mathematics and wonder, the next chapter of discovery began to take shape, the quest to approach the unattainable, and to glimpse what lies beyond the cosmic speed limit that defines all of reality. Through every era of human history, progress has been born from conflict, not only the wars fought across continents, but the quiet battles within the human spirit, the desire to know, to push further, to tear through the boundaries that cage understanding. It is this restlessness that defines the species. From the first stone tools to the engines that breach the stratosphere, humanity has always sought to conquer limits. Each frontier reached was once a forbidden edge. Each barrier shattered a moment of triumph over the impossible. But with every victory came a question that echoed more deeply. If limits exist for a reason, what happens when we defy them all? When the 20th century dawned, this conflict took a new form, not against nature's landscapes, but against nature's laws. The sound barrier, once thought unbreakable, fell before human ingenuity. jet engines roared past it, proving that resistance could be conquered with understanding. But even as that victory echoed through the skies, a new, more profound barrier loomed ahead, the speed of light, the ultimate frontier. To touch it would not merely be an achievement of engineering, but an act of cosmic defiance. It was the difference between observing creation and stepping into its machinery. And for the first time in history, the tools of physics began to offer a glimpse of what that might mean. In the years following Einstein's revelation, minds across the world grappled with the enormity of his idea. Hendrik Lorentz, whose equations had hinted at time dilation before Einstein, struggled to reconcile the strange symmetry of space and time. Henri Poincaré approached it as a philosopher-mathematician, foreseeing the geometry of relativity but hesitating to strip away the comfort of an absolute universe. And then came Hermann Minkowski, Einstein's former teacher, who gave form to the revelation itself, the four-dimensional fabric of space-time, where time was not a flow, but a dimension. Together, these thinkers forged the conceptual architecture that would guide physics for a century. Yet, beneath their achievements ran a common thread of unease. The closer their theories came to the truth, the more they seemed to unravel reality itself. By mid-century, the pursuit had grown from equations into monumental machines. In hidden laboratories and sprawling facilities, particle accelerators became the new cathedrals of discovery. Within their circular corridors, protons and electrons were hurled to speeds approaching that sacred constant to 99.999%, the speed of light. At those velocities, their masses swelled, their lifespans stretched, and time itself seemed to warp. Humanity was no longer theorizing relativity. It was recreating it. Yet the closer the particles came to light speed, the more violent the struggle became. Energy requirements soared exponentially, and the machines groaned under the burden of nature's law. The message was clear. Light speed was not a threshold to cross, but a wall to approach infinitely, a horizon that mocked the dream of transcendence. Amid these triumphs, darker questions began to surface. During the Cold War, the same equations that described the energy of light became the foundations of destruction. E equals mc was no longer a symbol of enlightenment. It had become a warning. The conversion of mass into pure energy, once an abstract beauty of physics, was unleashed in the blinding flash of atomic fire. Cities were vaporized, generations scarred, and the world was forced to confront a truth that Einstein himself had feared, that the human hunger for knowledge is inseparable from the capacity for ruin. The race for light had turned into a race for power, and the line between discovery and devastation blurred beyond recognition. Yet, even in those shadows, the pursuit continued. In the depths of CERN and Fermilab, scientists began probing matter at scales smaller than atoms, searching for the origins of mass itself. They spoke of Higgs fields and quantum symmetries, of invisible energies that stitched space-time together. Every new particle discovered, every anomaly detected, was a step closer to understanding the very laws that restrained them. And within those corridors of data and steel, an unspoken tension haunted the air, a silent question that no instrument could measure. If humanity ever reached light speed, if it truly touched the fabric of space-time, would it transcend or disappear? The emotional weight of this question fell heavily on the minds that carried it. Some, like Oppenheimer, felt the burden of their own brilliance. He had glimpsed what it meant to awaken forces once reserved for stars and gods. And in that moment of revelation, he whispered words that defined an age. "Now I am become death, the destroyer of worlds." The same knowledge that illuminated the universe had also revealed the abyss. Progress and peril were no longer opposites. They were reflections of each other. bound by the same relentless curiosity to chase light. Then is to confront the paradox of being human. The dream of reaching it is the dream of immortality, of breaking free from decay and time. Yet to grasp it fully may mean erasing what it means to live at all. The laws of physics stand not as punishments, but as protections, holding creation together through balance. When humanity strains against those laws, it must ask whether the act of reaching the impossible is worth the cost of losing itself. And so, the story of light is not only the story of science, it is the story of the human soul, reaching for something it was never meant to hold, yet unable to stop reaching. In the glow of every reactor, in the hum of every collider, the same silent truth lingers in pursuit of the light. Humanity has found both its greatest illumination and its deepest shadow, and somewhere beyond the walls of theory and machinery, the question remains, if we ever find a way to touch that light, will we discover transcendence, or the end of everything we understand? As the 20th century gave way to the dawn of the digital and atomic age, the pursuit of the unattainable did not fade. It evolved. The laboratories grew quieter, but the ambition only deepened. Across the world, satellites orbited like silent witnesses to human persistence, their clocks constantly corrected by the very relativistic effects Einstein had foretold. In those small adjustments, microseconds stretched by motion and gravity, the theory became tangible. Every global position, every digital map, every navigation system depended on the universe's subtle bending of time. Humanity had not broken the speed of light, but it had learned to live within its shadow, to harness the fabric of space-time itself for its own survival. The dream of reaching light speed remained distant, yet its influence touched every heartbeat of civilization. Still, for those at the edge of physics, contentment was impossible. The more was known, the more the unknown grew. The Large Hadron Collider, a ring of steel and magnetism beneath the soil of Europe, became the next expression of human defiance. A machine built not just to observe particles, but to recreate the first moments after the Big Bang within its depths. Protons raced at 99.999999% the speed of light, colliding in bursts of energy hotter than the cores of stars. For the briefest moments, matter transformed into pure light and back again, echoing the cosmic conversion that defined E equals mc. It was not merely an experiment. It was a controlled dialogue with creation itself. But as data streamed from detectors, there was also humility in every discovery. Each breakthrough whispered a warning that every approach toward light revealed more layers of resistance, as though the universe were guarding its deepest secret. Behind an invisible threshold, the men and women who devoted their lives to this quest often lived in a quiet duality, the exhilaration of knowing they were peering closer to ultimate truth, and the loneliness of realizing how far that truth remained. In the silence of observatories and underground tunnels, they faced the same existential conflict that haunted their predecessors. To understand the universe was to risk understanding how fragile human meaning truly was. For what is life, if time itself can stretch and slow? What is individuality, if energy and matter are the same? In that paradox lay a haunting beauty that humanity's greatest discoveries always reflected its deepest vulnerabilities. The Cold War had shown what happened when knowledge outpaced wisdom. Entire nations bent the discoveries of relativity toward destruction, creating weapons that mimicked the sun. Yet in later years, those same equations were repurposed for peace, to study fusion, to understand cosmic rays, to simulate black holes. Science had become both a mirror and a compass, revealing not only how the universe worked, but who humanity chose to be within it. The physicists of the New Age understood this duality. They spoke less of conquest and more of reverence. To study light was no longer about breaking it. It was about listening to what it had always been saying, that the universe is balance, not defiance, harmony, not dominance. Yet even now, deep within the data and theories, a spark of longing persists, an ancient whisper carried through every mind that stares into the stars. It is the voice that wonders not just what lies beyond the speed of light, but why that boundary exists at all. Perhaps it is not a wall, but a veil, one that protects the rhythm of time and matter, ensuring that consciousness remains anchored within experience. For if humanity ever crossed that veil, it might not emerge as what it once was. It might become light itself, eternal, everywhere and nowhere. The human conflict of discovery is, in truth, a dialogue between mortality and infinity. And though the equations are silent, their meaning is clear. To reach the light is to risk becoming part of it. In that tension between the yearning to transcend and the need to remain lies the essence of what it means to be human. For perhaps the universe does not deny humanity light speed out of cruelty, but out of mercy. It keeps the dream always within sight, yet forever just beyond reach, ensuring that the species continues to strive, to question, to wonder, and in doing so, to live in the heart of the modern age, buried beneath mountains and cities. Humanity built machines that rivaled the grandeur of myth. They were not temples, yet they sought communion with the divine, not gods of flesh and stone, but the gods of energy and motion. These were the particle accelerators, the great rings of magnetism and light, where humankind began its most audacious experiment to reach the very brink of the possible. Within their circular corridors, particles were flung through vacuum tunnels, spiraling closer and closer to the ultimate speed limit. As they accelerated, the universe itself began to bend around them, and the old Newtonian clockwork of motion shattered at 99.9999999% the speed of light. Matter began to reveal its hidden resistance. Every fraction closer to that sacred threshold demanded exponentially more energy, as though nature itself were tightening its grip. The equations predicted this beautifully and mercilessly. E equals mc to E equals gamma, mc to E equals gamma, mic to, where the factor gamma, 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 the Lorentz multiplier, grew without bound as velocity neared light speed. In essence, the faster something moved, the heavier it became, not from added matter, but from the warping of space-time's geometry itself. The universe was not merely pushing back, it was reshaping reality to preserve its order. In those accelerators, humanity could see the invisible scaffolding of the cosmos strain, shimmering between possibility and impossibility. Physicists watching these collisions were not just studying particles, they were witnessing time itself deform. In the fleeting existence of a morn or a kaon, they saw the echo of cosmic truth, that time is not constant. A particle racing near light speed lives longer than one at rest. Its internal clock ticks slower, its decay delayed. Even in the smallest fragments of matter, the universe whispers its secret. The closer one moves to light, the slower one moves through time. In laboratories around the world, this was no longer theory but measurable fact. The same principle that governs the passage of galaxies applied equally to the trembling path of a single electron. To describe such motion is to describe a paradox. The mathematics insists that at the exact speed of light, mass would become infinite, and time would cease altogether. But infinity is not something the universe allows within itself. It is a concept that hovers just beyond reach, a destination that exists only as a limit. The closer the particles came, the more violently they resisted, as if creation itself had placed a guardian at the threshold. The physicists came to call it the cosmic speed limit, not out of defeat, but reverence. They had glimpsed the asymptote, the place where energy curves toward forever, but never touches it. It was as if the universe were whispering a message through mathematics. You may approach my light, but you may never become it. To visualize this, one might imagine a runner chasing their own shadow at sunset. No matter how fast they sprint, the shadow remains just ahead, bound by the same geometry of light that defines their world. The runner may narrow the gap until it seems within reach, but it never closes, for light is not just speed. It is the boundary that defines all speed. It is the measure by which motion, distance, and time find meaning. And so, as those particles raced through rings of steel and magnets, humanity glimpsed not failure, but the perfection of nature's design. In that perfection lay both beauty and frustration. The accelerators proved what Einstein had foreseen, that the laws of relativity are absolute, not suggestions to be overcome. The faster a particle moves, the more energy it demands, until the numbers climb toward infinity. Even if every watt of the sun's power were funneled into a single proton, it would still fall short of reaching light speed. This was not an engineering flaw. It was a cosmic principle. The universe was self-consistent, perfectly balanced, and utterly unforgiving. Yet paradoxically, this limit inspired rather than discouraged. It did not end the dream. It refined it for the first time. Humanity saw that light speed was not a wall, but a mirror reflecting the structure of reality itself. Through those high-energy collisions, they discovered the Higgs field, the invisible ocean through which all particles swim, gaining mass as they move. The more they tried to accelerate through it, the heavier they became, as though the universe were ensuring that no traveler could escape its temporal tether. The laws of physics did not imprison matter out of cruelty. They did so to preserve coherence, to keep time, energy, and space in unison. And yet, beneath this perfect order, the human imagination refused to yield. If energy and mass were bound by such symmetry, perhaps there were other pathways, ones hidden in dimensions beyond sight, or in the quantum foam beneath spacetime's surface. Scientists began to speculate about tachyons, hypothetical particles that could exist beyond light speed, moving backward through time. No evidence has ever confirmed their existence, but their idea remains a haunting symbol of human defiance, the refusal to accept any frontier as final. For now, the experiments continue, each one more precise, each collision peeling back another layer of reality. In the tunnels beneath Geneva and the mountains of Japan, in superconducting rings cooled to near absolute zero, humanity keeps inching toward that unreachable speed, not to conquer it, but to understand why it cannot be conquered. In that pursuit lies the true essence of science, not in breaking the rules, but in listening to what those rules reveal. And as the hum of the accelerators fades into the night, one truth becomes clear, even with all its machines, all its intellect, and all its will, humanity remains a slow traveler through space-time. But perhaps that slowness is not failure. Perhaps it is grace. For in the act of moving, of learning, of never quite arriving, humanity becomes something light itself, can never be a creature of time, capable of wonder. And from that wonder arises the next step, a journey not of speed, but of imagination, where physics ends and possibility begins, beneath the steady pulse of those accelerators. As magnets hummed and data flickered across control room screens, something quietly profound was unfolding. It was not just the collision of subatomic particles, but the collision of human ambition with the architecture of the cosmos. Each burst of energy, each luminous spray of particles recorded by detectors, told a story written in the most ancient language, that of symmetry, entropy, and the limits of causality. These collisions were windows into creation itself, tiny echoes of the Big Bang, when light and matter first danced into existence. And in those fleeting moments, as particles were born and annihilated within a trillionth of a second, physicists glimpsed a haunting symmetry that to chase light is to confront the origins of everything. The further humanity ventured into this subatomic wilderness, the more it became clear that the universe is not built for shortcuts. Every attempt to accelerate matter closer to light speed illuminated the invisible cost of motion. Energy did not merely push, it warped, it twisted, it bent time around the traveler like a cloak of resistance. A morn, for instance, which should decay in microseconds, survives far longer when moving near light speed. Time stretches for it. To the muon, the universe seems calm and slow. To the observer, it races through space before vanishing. This quiet defiance of experience reveals a truth, both majestic and unsettling, that the faster one moves through space, the slower one moves through time. The cosmos, it seems, compensates for every gain, keeping the total balance perfect. And yet, even with this knowledge, the experiments continued, not from ignorance, but from reverence. In the controlled violence of these collisions, humanity found the rhythm of the universe repeating itself in miniature. Detectors like Atlas and CMS at CERN recorded the whispers of particles that existed for less than a blink, each confirming that the laws written at the dawn of time still govern the present. Quarks danced, leptons scattered, photons burst free, and all obeyed Einstein's unyielding speed limit. It was as if the cosmos were reaffirming its promise. There are boundaries, and within them, perfection, still in the quiet between experiments. As the beam shut down and the tunnels cooled to silence, an existential unease crept in. What if the limit was not meant to be crossed because it defines what life is? Light does not experience time. It never ages, never changes, existing everywhere along its path at once. To become light, to reach its speed, would mean to step outside of time, to surrender identity, motion, memory. Perhaps the reason matter can never reach light speed is that to do so would be to dissolve into the fabric of space-time itself, to cease being something separate. In that sense, the barrier is not punishment. It is protection. It keeps life within the realm of becoming, rather than being, within the story, rather than the conclusion. As velocity nears the cosmic threshold, the universe itself begins to twist into unfamiliar shapes. What was once the calm expanse of stars becomes a storm of light. The heavens, once scattered and infinite, collapse into a single, burning tunnel ahead, a distortion of perception born not from illusion, but from truth. This is relativistic aberration, the visual language of near-light motion. Every photon, once arriving from across the cosmos, bends forward, compressed into a blinding cone of radiance. Stars that once surrounded the traveler now blaze in a single direction. The front their light, blue shifted into higher and higher frequencies until even visible wavelengths vanish into ultraviolet, then X-ray, then gamma. The cosmos no longer shines. It sears. Beyond this speed, light ceases to comfort. The cosmic microwave background, the quiet relic of the Big Bang, becomes a deadly sea of radiation. Its once gentle 2.7 Kelvin glow turning into a wall of lethal heat. The faster the ship moves, the more violent the universe becomes. as if creation itself resists intrusion into its sacred boundary. Each atom of hydrogen in the void, once benign, now strikes the hull with catastrophic energy, transforming interstellar dust into streams of cosmic bullets. Space, once empty, turns hostile. It becomes a field of fire. And yet, in that fury, time begins to stretch. From the traveler's frame, seconds pass slowly, calmly, like the quiet pulse of a heartbeat in a dream. Outside, entire centuries unfold in the blink of an eye. The stars evolve, die, and are reborn in the space of a moment. Galaxies drift and collide, while the traveler, enclosed in a cocoon of slowed time, witnesses eternity as a static horizon. It is a paradox so elegant and cruel that it defines relativity itself. To move through space is to surrender movement through time. The closer one approaches light speed, the slower the clock beats, until finally it threatens to stop altogether. Mass 2. Rebels. It rises inexorably, like an ocean under a growing moon. The ship's inertia swells until it becomes infinite, demanding infinite energy for the smallest increase in speed. Every engine, every reactor, no matter how advanced, would face the same verdict: exhaustion. Even the most powerful known forces in the universe, the magnetic fields of neutron stars or the gravity wells of black holes, cannot propel matter beyond light. In this way, the cosmos enforces its law not through destruction, but through impossibility. It does not forbid the attempt, it simply ensures the failure as speed climbs toward light's domain. Perception itself begins to fracture. Distance no longer behaves. Dimensions blur. Ahead, the universe seems compressed into a single plane, a radiant sheet of white fire. Behind, darkness swallows everything, the past erased by the impossibility of catching up to one's own light. Space and time, once distinct, fuse into a single continuum, where cause and effect begin to lose meaning. At such velocity, what does it mean to move forward when forward no longer exists in the same way? What does it mean to have a beginning when time itself folds? Perhaps this is the ultimate revelation hidden within Einstein's equations, that light speed is not just a limit of motion, but of experience. It is where the language of human understanding ceases to apply, where words like before, after, distance, and duration collapse into one another like waves meeting in silence. To touch that speed is to confront the raw geometry of existence, to glimpse the scaffolding upon which reality is built. And somewhere, in that blinding horizon where matter breaks and time halts, lies the ultimate mystery. For if a photon has no mass, no time, and no path through space-time as we understand it, then what is light? Is it motion without journey, existence without experience? Or is it the purest state of being, a reminder that to be everywhere at once, one must surrender the privilege of moving anywhere at all? As humanity's imagination reaches toward this sacred boundary, the question deepens beyond physics. To transcend light is to challenge the nature of reality itself. And so, standing at the edge of science, where equations dissolve into wonder, the universe whispers a final truth. Not everything unreachable is meant to be attained. Some boundaries exist to preserve the shape of existence, to remind consciousness that even in infinite possibility, there must remain mystery. At these extreme velocities, even the familiar becomes alien. The stars no longer retain their soft pinprick shapes. They elongate into streaks of brilliance, stretching toward a vanishing point, each one a thread in the tapestry of a warped cosmos. The familiar night sky, which once offered comfort and continuity, dissolves into abstraction. Galaxies, once islands of calm, appear as compressed disks. Their light, fused and distorted, colors shifted beyond human comprehension. It is a vision at once terrifying and sublime, a panorama that betrays the universe's underlying geometry, revealing the hidden skeleton of space-ra, the traveler. If such a consciousness could survive these conditions, would feel existence itself pressing inward. Space ahead compresses, but space behind stretches indefinitely. Every motion, no matter how precise, feels disproportionate, as if the laws that govern ordinary life have been rewritten to accommodate the extreme. Simple notions of up and down, left and right, begin to fracture. The mind struggles to reconcile the visuals with the laws of memory, and perception begins to fail. Sound, too, becomes meaningless. At such speeds, any traditional signaling is overtaken by the distortion of causality. One begins to understand, viscerally, that near-light travel is not merely a challenge of engineering, but a confrontation with the very limits of human cognition. Within this tunnel of brilliance, time itself behaves as a pliant material. Seconds elongate into centuries, centuries shrink into the blink of a thought. An observer moving at near-light speed could witness the life cycle of stars, from birth to supernova, in the span of a single journey. The universe, normally measured in incomprehensible epochs, becomes simultaneously tangible and alien. To experience this is to witness existence at its most raw and unmediated, a universe unshackled from human scales, moving according to principles that defy intuition. And yet, even in this overwhelming torrent, there is symmetry. Light remains constant. The cosmic heartbeat that orchestrates every fold of time and space. Mass grows relentlessly as well. The ship, or any object, gains inertia in a way that is not linear but exponential. Each additional increment of speed demands more energy than all that came before. Engines and fuel, no matter how advanced, face the same universal law. Infinity lies just beyond reach. The more one pushes, the more the universe asserts itself, a silent, immovable force. Motion becomes a dialogue between ambition and limitation, and the impossibility is not a failure of technology, but a declaration of cosmic design. The closer matter approaches light, the more reality itself seems to conspire to preserve its boundary. Philosophically, this is a meditation on impermanence and perspective. At near-light speeds, the traveler exists in a paradox, moving toward everything while experiencing almost nothing in traditional terms. Distance and duration collapse into abstraction. Cause and effect blur. One begins to understand that speed is not merely a metric of motion, but a measure of experience. The universe resists infinite velocity not out of caprice, but because perception and time are intertwined, because existence as a narrative demands pacing. To surpass that speed is not just impossible for matter, it is incomprehensible for consciousness. And yet, in imagination, the mind can traverse these boundaries. Speculative theories, warp drives, wormholes, and higher dimensions hint at paths where the universe might be navigated without violating its sacred limits. Here speculation becomes a bridge, a way to explore the frontier of reality without defying its fundamental laws. The edge of physics thus becomes the edge of thought, where the known blends seamlessly into the possible, and where human creativity illuminates the contours of a universe that is otherwise impervious. At this extreme edge, one realizes that approaching light speed is not a story of triumph, but of revelation. It is a confrontation with the architecture of existence itself, where every particle, every photon, every heartbeat of time asserts the elegance and unyielding consistency of natural law. And in this confrontation, the greatest lesson emerges. The universe is not a canvas for ambition alone, but a mirror reflecting the limits of perception, the sacred boundary beyond which matter may not pass, and the infinite horizon at which imagination alone can reach. In the framework of mainstream physics, the speed of light stands as an unyielding sentinel, marking the boundary between the possible and the eternally forbidden. Einstein's theory of relativity leaves little room for debate. As any object with mass accelerates toward the speed of light, its relativistic mass grows without bound, requiring energy that climbs toward infinity. No engine, no fusion reactor, no concentration of antimatter could ever supply enough force to overcome this law. It is not a technological challenge, but a statement of cosmic governance. The universe, in its elegance, enforces this limit with the subtlety of mathematics and the inexorability of natural law. To even imagine a vessel reaching light speed is to step into the abstract, to contemplate an act that the cosmos itself forbids. Photons, however, exist in a realm of pure paradox. Massless yet tangible, they traverse the universe at exactly c, the sacred constant. From their perspective, there is no passage of time, no distance as humans understand it. Every photon emitted from a distant star arrives instantaneously along its own trajectory, though eons may have passed for any observer. In this way, light itself is both a messenger and a boundary, a glimpse into how existence can move without aging, traveling without encountering resistance. It is a standard against which all motion is measured, a reminder that the universe allows some beings to traverse the cosmos unbound by time, while others' matter, life, consciousness remain tethered to its flow. Humanity has, of course, attempted to approach this limit through ingenuity. Ion drives, with their relentless low-thrust propulsion, offer a whisper of acceleration over decades. Antimatter engines, theoretically the most efficient conversion of mass into energy, promise bursts far beyond chemical rockets, yet even these remain orders of magnitude shy of what would be required. Photon sails, those vast sheets that ride the pressure of light itself, could accelerate spacecraft gradually, pushing closer to sea than conventional engines, but still without ever crossing the threshold. Every proposal meets the same immutable wall. The universe does not merely resist, it demands obedience. The problem is not engineering, but energy. Even the annihilation of matter and antimatter, the most efficient process known, converts only a finite amount of mass into usable propulsion. To push a single kilogram to near light speed would require energy rivaling the output of entire stars. To attempt full light speed is to chase infinity itself, a pursuit destined to collapse under the weight of the cosmos. It is a limit written into the structure of space-time, a natural law not imposed by human imagination, but discovered through centuries of observation, calculation, and experimentation. Yet within this impossibility lies profound insight. The relativistic barrier is not a punishment or a failing of technology. It is an expression of the universe's harmony. Mass, energy, time, and space are woven together, each constrained and balanced. The laws of physics preserve this equilibrium, ensuring that matter cannot outrun its own existence. It is a boundary that teaches rather than denies, illustrating that the architecture of reality is both beautiful and immutable. And still, the mind cannot rest at limits. Mainstream science defines the rules, but it also illuminates the edges where creativity begins. The impossibility of reaching light speed does not close the door. It opens a window into thought experiments, near-light travel scenarios, and cosmic possibilities that remain within the realm of law. By understanding photons, relativistic mechanics, and the energy constraints of propulsion, humanity is not merely constrained, it is equipped to imagine, to simulate, and to explore, to test the architecture of the universe itself, without violating it. In this way, the so-called barrier becomes a starting point, a canvas on which the imagination sketches the outlines of journeys yet untraveled, even as mainstream science asserts the immovability of the speed limit. It simultaneously illuminates the vast corridors of possibility that lie just beneath it. Spacecraft traveling at a fraction of light speed would already experience the strange and poetic consequences of relativity, time dilation, length contraction, and the warping of visual perception. For decades-long journeys to distant stars, centuries could pass for the rest of the universe, while the traveler's age only decades. This is not science fiction, but a tangible consequence of equations verified by atomic clocks aboard high-speed jets and satellites. It is the universe revealing its rules with both clarity and cruelty. Even in obeying them, humans touch the extraordinary, approaching the threshold without ever crossing it. Near-light propulsion concepts push this principle further, exploring how energy might be applied most efficiently. Ion drives, slow and steady, illustrate patience as a form of genius. They can, given enough time, propel a craft toward relativistic speeds. Antimatter engines promise sudden bursts, converting every fraction of a gram into prodigious energy. Yet even these fall short of the infinite requirement demanded by light speed. Photon sails, riding the gentle pressure of starlight or laser arrays, move with elegance rather than brute force. Each concept, though limited by physics, embodies the audacity of thought, the courage to imagine movement against the very grain of the cosmos. The lesson of photons is central to understanding this frontier. They are not simply messengers of light, they are paradox incarnate, massless, eternal, traversing space-time without experience or decay. They reveal a reality in which motion and time are unbound from the limitations that govern matter. To study them is to confront the difference between what exists and what is experienced. Humans, bound by mass and temporality, cannot achieve what photons do effortlessly. Yet by observing and modeling them, science glimpses a plane of possibility that is otherwise inaccessible. In their motion, there is perfection, a standard against which all attempts to accelerate are measured. Energy calculations make the futility of full light-speed travel undeniable. Yet they also inspire awe. To accelerate even a modest mass to 90% of c requires energy on the scale of entire planetary systems. Approaching 99% demands energy beyond comprehension. Infinity looms, not as abstract mathematics, but as a physical reality, a wall against which human ambition is measured. The universe enforces this barrier consistently, without malice or compromise, a silent arbiter of what is achievable and what is forever theoretical. In this tension between law and imagination, mainstream science achieves a rare duality. It constrains while it liberates. By defining the boundaries, it allows speculation to take flight without contradiction. Science does not forbid imagining warp drives, light sails, or tachyonic possibilities. It only ensures that such visions remain consistent with observed reality. This interplay between impossibility and creativity shapes the frontier of human understanding. Even as relativistic mechanics asserts that matter cannot reach C, it also whispers a subtler truth. The closer one approaches, the more extraordinary the universe becomes, and the more profound the revelations that await within the permitted margins of motion. Here, at the interface of law and imagination, the mind can wander through scenarios of interstellar travel, accelerated time frames, and near-light phenomena, all while grounded in rigor and observation. The impossibility of surpassing light does not diminish wonder, it sharpens it. It transforms the barrier into a lens, revealing the exquisite architecture of the cosmos and the subtle balance that governs every atom, photon, and heartbeat. In understanding these constraints, humanity learns not only the rules of the universe, but the art of approaching its sublime limits, where physics and philosophy converge, and where the journey itself becomes the revelation, at the frontier of imagination, where rigorous physics yields to speculation. Humanity begins to explore what might exist beyond the unyielding barrier of light speed. Here, equations stretch into thought experiments, and the universe becomes a canvas for ideas that skirt the edges of the possible. The Alcubierre warp drive, for instance, is not merely a fantasy of science fiction, but a mathematical construct that envisions a vessel encased in a bubble of space-time itself. By contracting space ahead and expanding it behind, the ship could, in theory, reach distant stars without locally exceeding light speed. In this vision, motion is replaced by deformation, a bending of reality that allows the traveler to traverse cosmic distances, while the speed limit remains unbroken within their own frame. It is a radical reimagining of movement, a glimpse into how physics might be subtly circumvented without defying its fundamental rules. Beyond macroscopic engineering concepts, the quantum world tantalizes with hints of loopholes in nature's constraints. Quantum tunneling suggests that particles can, with minuscule probability, appear instantaneously across barriers that classical mechanics forbids. Entanglement allows information, in some interpretations, to exhibit correlations that seem faster than light. Yet, these phenomena do not permit matter to travel at or beyond C. They are whispers, not doorways. Still, they invite philosophical reflection. If information can escape local causality, then perhaps knowledge, in some abstract sense, can traverse realms forbidden to mass. Light speed becomes not merely a physical threshold, but a conceptual frontier where reality itself is questioned. The pursuit of faster than light. Travel carries profound consequences for the structure of time. In relativity, exceeding c is synonymous with violating causality. Actions could occur before their causes, histories could fold into futures, and paradoxes multiply like shadows in a storm. A ship that reaches or surpasses light speed would not merely traverse space. It would unsettle the linearity of existence itself. The past, present, and future could collapse into a single, incomprehensible instant, leaving consciousness adrift in an undifferentiated now. The very framework that allows experience, memory, and consequence to exist would unravel, revealing the universe as a lattice of probabilities rather than a sequence of events. In imagining light speed, humanity confronts not only technological impossibility, but the fragility of reality itself. Speculative theories extend further still into the interplay of space-time and exotic matter. Negative energy, cosmic strings, and higher dimensional shortcuts hint at the possibility of bending the cosmos to human will. But all remain firmly theoretical. No evidence yet supports the feasibility of constructing or surviving such mechanisms, and each introduces challenges that strain imagination as much as mathematics. They underscore the delicate balance of the universe. Every law that forbids faster-than-light motion also preserves order, causality, and coherence. To tamper with that balance is not merely to challenge physics, it is to flirt with the architecture of existence. And yet, the allure remains irresistible. To conceive of warp bubbles, tachyons, or temporal shortcuts is to glimpse a domain where science converges with philosophy. The pursuit of light speed transforms into a meditation on limits, possibility, and the nature of being. It is no longer a race against technology or energy, but a reckoning with what it means to exist within a temporal and spatial framework. Here, the human mind stretches to confront infinity, to imagine the consequences of transcending its own dimension of reality, and to wrestle with the paradox that the ultimate journey may not be through space at all, but through understanding itself in this speculative terrain. Light speed becomes more than a number or a velocity. It is a mirror reflecting the boundaries of knowledge, perception, and morality. It is a horizon at which physics, philosophy, and imagination converge, where every step forward demands not only calculation but contemplation. And as the mind wanders through these possibilities, one truth becomes clear. The pursuit of light speed is never simply about arriving. It is about facing the sublime, the unknowable, and the consequences of confronting the very fabric of reality. In contemplating these speculative frontiers, one is struck by the duality of promise and peril. Warp drives, tachyons, and quantum loopholes suggest pathways around the cosmic speed limit, yet each carries shadows as profound as their light. The Alcubierre bubble, for instance, demands not just exotic matter, but negative energy densities that may not exist in sufficient quantities, and even if they did, their manipulation could ripple violently through space-time. Tiny miscalculations in such a construct might create gravitational shocks, catastrophic distortions, or even the collapse of the very bubble meant to preserve life. In the pursuit of light speed, the universe appears simultaneously generous and merciless. The rules invite speculation, but reality enforces discipline with subtle, absolute rigor. Hypothetical particles that always move faster than light further challenge intuition. In theory, they exist beyond causality, their motion inverting the relationship between cause and effect. To detect or harness them would require rethinking time itself, confronting the philosophical core of experience. If a message could travel backward in time, could knowledge arrive before the event it describes? Could action precede intention? These questions move beyond engineering and physics into the realm of ethics and consciousness, suggesting that reaching for light speed may demand moral as well as technological reckoning. It is not merely a matter of energy or propulsion, but of responsibility to the very structure of existence. Quantum phenomena, subtle and elusive, add another layer to the narrative. Entanglement and tunneling suggest that information may transcend local limitations, hinting at a universe where connectivity is instantaneous, even if matter is bound. These effects, confirmed in laboratories around the world, remind us that light speed is not an absolute boundary for knowledge, only for mass. Perhaps, in the quantum domain, light speed is not the limit of what can be known or inferred, but of what can be physically done. Here, science offers both constraint and liberation, while matter cannot outrun light. Thought and information may glimpse beyond it, illuminating possibilities that physical reality will never permit. This speculative domain raises profound philosophical questions. If humanity could somehow reach light speed, or approximate it through loopholes, what would it mean to experience existence? Would consciousness survive the collapse of time into simultaneity? Or would perception itself fracture, leaving awareness scattered across possible time? The pursuit of light speed becomes less a technological endeavor and more a meditation on the nature of experience, identity, and causality. In imagining the consequences, one realizes that some boundaries are not merely physical, but existential, embedded in the very framework that allows the universe to be coherent and intelligible. And yet, despite these warnings, imagination presses forward. Speculation fuels the desire to probe, to model, to understand what lies at the edge of possibility. It is a testament to human curiosity, to confront impossibility and turn it into a lens for understanding, to use the unachievable as a measure of knowledge, and to frame questions that define the limits of perception and comprehension. In this sense, the fringe theories of light-speed travel are not failures, but mirrors, reflecting the extraordinary interplay between physics and philosophy, ambition and restraint, the known and the unknowable. Thus, the pursuit of light speed through warp bubbles, tachyons, and quantum quirks becomes a journey not toward a destination, but into understanding itself. It is a confrontation with paradox, a test of imagination constrained by law, and a reminder that some horizons exist not to be crossed, but to inspire awe. At the edge of speculation, the universe whispers its most subtle truth. The laws that forbid light-speed travel are also the laws that make experience, history, and causality meaningful, and in that tension lies the deepest mystery of all. In laboratories across the globe, the frontier of speed is no longer only a theoretical pursuit. It has become a living, tangible endeavor. At CERN, particle accelerators hurl subatomic particles to velocities infinitesimally shy of light speed, their collisions illuminating the underlying fabric of reality. Each experiment, though microscopic, resonates with cosmic significance, revealing how mass, energy, and space-time interact under the most extreme conditions. The Large Hadron Collider, in its subterranean ring, is a testament to human ingenuity, a machine that approaches the sacred threshold of C with particles too small to see, yet whose behavior echoes the laws that govern every star, planet, and photon in the universe. Beyond the particle scale, humanity dreams of bridging the gulf between stars. NASA and private initiatives like breakthrough Starshot Envision probes capable of approaching a fraction of light speed, miniature emissaries that could reach neighboring star systems within a human lifetime. These spacecraft are not powered by conventional rockets, but by lasers and photon sails, pushing tiny masses with relentless beams of light, even traveling at 20% of C. Such probes would experience relativistic effects, time dilation, blue-shifted starlight, and the subtle warping of perception. Each step toward the speed of light, however incremental, is a step into the unknown, a rehearsal for journeys that stretch imagination and patience alike. Yet the practical challenges are monumental. At near light speeds, interstellar space is no longer empty. Cosmic radiation, hydrogen atoms, and dust particles become deadly projectiles. Shielding a spacecraft or a human crew from such impacts requires energy and ingenuity beyond our current capabilities. Energy itself remains the ultimate constraint. Accelerating even a tiny probe to relativistic velocities demands power on astronomical scales. Life support, communication delays, and the psychological weight of isolation amplify the difficulty. Each proposal, each simulation, balances ambition with the sobering reality of nature's laws, reminding us that exploration is as much a question of endurance and adaptation as it is of propulsion. And yet, there is hope in incremental progress. Even modest velocities, a few percent of C, open the possibility of interstellar observation, allowing humanity to study exoplanets and cosmic phenomena directly, rather than through the slow, dim lens of light years. These small steps, though dwarfed by the absolute barrier, embody the essence of exploration, persistent curiosity, meticulous preparation, and the courage to confront limits without being defeated by them. The pursuit is not merely technical, it is philosophical, a reflection of the human spirit that seeks to touch the distant, to measure the impossible, and to understand its place in a vast and indifferent cosmos. Simulations of relativistic travel offer another lens into this frontier. Using high-powered computers and detailed models, scientists explore how near-light motion warps space and time, how radiation fluxes might behave, and how communication with distant probes could remain viable. These virtual journeys illuminate possibilities and dangers alike, allowing the mind to traverse what the body cannot. In them, we see a rehearsal of the human story against the immutable backdrop of the universe, the attempt to go further, faster, and to glimpse what lies just beyond the reach of physical reality. Emotion permeates these efforts. The scientists, engineers, and dreamers behind CERN, NASA, and Starshot confront paradox, limitation, and risk with a quiet resolve. Fear is present. Fear of failure, of futility, of the cosmic indifference that will outlast any human endeavor. Yet it is outweighed by wonder. The drive to explore, to push closer to the ultimate speed limit, is not born of recklessness, but of a profound need to understand, to witness, and to reach beyond what has been touched before. Each experiment, each simulation, each laser pulse across the void, is an expression of humanity's refusal to accept boundaries without first measuring their contours, probing their edges, and imagining what it would mean to transcend them. And as these efforts continue, the realization deepens. The barrier of light speed is not merely a technical challenge, nor even a physical one alone. It is a mirror reflecting the limits of energy, matter, perception, and imagination. The closer we approach it, the more evident it becomes that this threshold defines not just motion through the cosmos, but the very structure of reality itself. To reach toward light speed is to confront the architecture of existence, to test the interplay of law and possibility, and to acknowledge that every advance brings both illumination and a humbling reminder. The universe is vast, the speed of light immutable, and the pursuit of its boundary as much a philosophical journey as a scientific one. Even as humanity inches closer to relativistic travel, the experiments and missions reveal another, quieter truth. Light speed is as much a limit of experience as it is of physics. At near-light velocities, the universe no longer appears as a familiar stage, but transforms into a canvas of extremes. Stars ahead compress into intense arcs of blue-shifted brilliance, while radiation, once harmless, becomes a torrent of lethal energy. The very space between particles, once a void, is filled with peril. Engineers and physicists must not only calculate propulsion and energy, but anticipate the alien environment that a ship traveling at such speeds will encounter. A world where motion itself is dangerous, and where survival demands ingenuity as profound as the equations guiding the trajectory. Modern efforts also highlight the delicate balance between scale and ambition. Breakthrough star shots, tiny probes weighing mere grams, can survive where human crews could not, their fragility offset by speed and distance. These missions are emblematic of a pragmatic philosophy. Even a fraction of light speed is sufficient to extend observation and knowledge across the stars. They remind us that exploration is rarely about the impossible leap. It is about incremental advances, understanding constraints, and daring to dream while respecting the laws that govern all motion. Each probe, each pulse of laser light, each simulation of relativistic effects is a testament to humanity's capacity to navigate the interplay between aspiration and reality. Yet, the pursuit of light speed carries philosophical weight. The boundary it represents is not merely energetic or technological, it is existential. Pushing closer, we confront the limits of time, perception, and causality. Clocks aboard near light speed vessels run differently than those left behind. Seconds stretch and contract, and the familiar rhythm of life is fractured. Observers aboard such craft would witness a universe evolving at a speed incomprehensible to stationary eyes, while distant civilizations would see the travelers almost frozen in time. This is a confrontation not with a machine or engine, but with the flow of existence itself, a reminder that every advance in velocity entails a simultaneous advance in perspective, revealing the relativity inherent in all experience. The work of modern scientists and engineers thus becomes a meditation on scale and consequence. Particle accelerators, laser-driven probes, and computational simulations are more than technical achievements. They are instruments of understanding, tools that allow humans to trace the contours of possibility without violating them. They teach that even in the face of insurmountable boundaries, knowledge can advance and imagination can flourish. By approaching light speed incrementally, humanity not only explores distant stars, but also explores the edge of comprehension itself, how energy, mass, time, and perception intertwine to define reality. Emotion permeates every aspect of these endeavors. The pursuit of near-light travel is driven by awe, by wonder at the vast distances between stars, and by a yearning to witness phenomena that otherwise remain forever beyond reach. Fear and respect accompany ambition. The consequences of miscalculation are not hypothetical, but existential. Radiation, relativistic mass increase, and communication delays are daily reminders of how fragile life and machinery are in the face of universal constants. Yet the drive to explore persists, a reflection of an intrinsic human quality, the desire to understand, to reach, and to touch what the cosmos conceals. In the quiet hum of laboratories, the shimmer of laser arrays, and the worry of computational models, the story of light speed unfolds. It is a narrative of perseverance, intelligence, and wonder, where each incremental step toward relativistic velocities illuminates not only distant stars, but the principles that govern all motion. And as these efforts progress, the lesson grows ever clearer. The barrier is not merely technical or energetic, but philosophical, a line that challenges humans to reconcile ambition with the immutable rules of the universe, and to find meaning in the pursuit itself, even when the ultimate goal remains forever beyond reach. In the quiet vastness of space, light is more than a velocity. It is a narrative, a story that stretches across time and distance, weaving together the universe in a single, relentless thread. For humans, the speed of light represents both possibility and impossibility, a frontier that beckons with wonder yet repels with absolute constancy. Every photon emitted from distant stars carries within it a memory of the past, a glimpse of worlds long vanished or yet to be understood, and in chasing that light, humanity chases more than knowledge. It chases meaning itself. The pursuit of light speed mirrors an intrinsic aspect of consciousness, the desire to transcend the boundaries that define existence, to glimpse the infinite without being consumed by it. Perhaps, in the end, the true significance of light speed lies not in reaching it, but in understanding it. It is a mirror reflecting the architecture of reality, revealing how energy, mass, time, and space intertwine to construct the cosmos we inhabit. The laws that forbid travel at sea are not constraints to defeat, but lessons in comprehension, reminding us that some boundaries are foundational, that limits are woven into the very nature of being. It is within this realization that philosophy and science converge. The quest to understand the universe becomes inseparable from the quest to understand ourselves. Consciousness, it seems, may be defined as much by the edges it cannot cross as by the horizons it can explore. photons, eternal voyagers of the cosmos, embody this paradox. They traverse light years without aging, witnessing every event along their path, yet remaining unaffected by the passage of time. They are free, yet bound, perpetual travelers in a universe that permits them motion without consequence. Humanity, in its dreams and machines, can approach their velocity, can simulate their perspective in equations and thought experiments, but can never inhabit it. To reach light speed is to aspire to a state that is both ultimate and unattainable, a condition of pure motion, of perfect awareness, unshaped by duration or decay. In contemplating this, humans are reminded of both the grandeur of existence and the humility it demands. The search for light becomes scent, a meditation on human desire. It is not merely a scientific endeavor, but an existential one, an attempt to reconcile ambition with limitation, curiosity with respect, imagination with law. Each laser pulse, each particle hurled at near light speed, each calculation simulating relativistic travel is a step toward insight, a way to approach the profound without violating it. In this pursuit, science and spirituality intersect. The cosmos, vast and indifferent, becomes a teacher, offering lessons in wonder, patience, and reverence. The speed of light is at once a rule and a metaphor, a boundary that shapes understanding and a beacon that inspires it. And as the narrative unfolds toward its conclusion, the image that lingers is of Earth, small and luminous, suspended in the darkness. Its blue light streams outward, crossing the void at sea, a constant witness to time and space, a signal that will travel far beyond the reach of any observer. In that light is both story and truth. The universe continues its course. Photons journey across eons, and humanity, though bound by matter and mortality, continues to dream, to reach, to question. The chase is eternal, not in defiance of law, but in affirmation of the mind's capacity to imagine, to understand, and to glimpse, however fleetingly, the infinite that lies just beyond the possible. In the light we chase, we find both our limits and the essence of what it means to seek, to know, and ultimately to be. The pursuit of light speed, when viewed through the lens of human consciousness, becomes a meditation on our deepest impulses, the drive to know, to explore, and to transcend. Across millennia, civilization has been defined by its curiosity. The first astronomers charting the stars, philosophers pondering the nature of time, explorers risking their lives for horizons unseen. In this continuum, light speed is not merely a scientific problem. It is the ultimate expression of that impulse. It represents the intersection of intellect, imagination, and yearning, a threshold that cannot be crossed physically, yet can be approached conceptually, mathematically, and emotionally. The human spirit, in confronting this limit, reveals itself not in triumph over nature, but in the capacity to comprehend and revere it. To chase light is also to confront the ephemeral nature of experience. As speed increases, time stretches and contracts, and the familiar rhythm of life becomes malleable, almost alien. The mind envisions what it would be like to traverse the cosmos at velocities where minutes inside a vessel could equate to centuries outside, where stars blur into lines of radiant energy, and distances once incomprehensible collapse into perceptual tunnels. In imagining these extremes, we confront our mortality, our fragility, and the fleeting scale of human life against the backdrop of cosmic immensity. Light speed becomes a prism through which the finite and infinite are reflected, offering both awe and humility. Photons continue their silent journey across the universe, indifferent to our striving, yet symbolic of what we aspire to understand. They embody permanence without experience, freedom without intervention, and motion without constraint. By observing them, modeling their behavior, and theorizing about their properties, humanity glimpses a realm where the rules we live by, causality, duration, inertia, are irrelevant. It is a state of being that we cannot occupy, yet it defines the ultimate horizon of knowledge and imagination. In this light, the speed of light is less a barrier than a teacher, offering insight into the relationship between reality and perception, between matter and motion, between what is and what can be envisioned. The philosophical resonance of light speed extends into the very nature of limits. Perhaps it is precisely the impossibility of crossing sea that gives it meaning. Limits, after all, define boundaries, create structure, and shape consciousness. Without constraints, curiosity would lack direction, discovery would have no context, and reflection would lose urgency. The universe, in enforcing this ultimate boundary, provides a framework within which intelligence, imagination, and purpose emerge. In understanding why we cannot reach light speed, we learn not only about physics, but about the conditions that allow awareness itself to exist. And in the final contemplation, Earth appears suspended in the cosmic night, its blue glow casting a fragile halo against the infinite. Its photons journey outward, carrying the story of life, of thought, of yearning, at a pace that cannot be surpassed. Humanity, tethered to matter, can only watch, simulate, and dream. Yet in that very act of dreaming, we participate in the eternal voyage of light. The pursuit of speed becomes inseparable from the pursuit of meaning. To chase light is to chase understanding, to navigate the interface of knowledge and wonder, and to recognize that some horizons exist not to be crossed, but to inspire the profoundest reflection on what it means to exist in a universe at once boundless and beautifully constrained. The journey toward understanding light speed, at its core, is a journey into the nature of existence itself. While physics provides equations, constants, and boundaries, the human mind fills in the spaces between with wonder, reflection, and longing. Light is both a physical phenomenon and a metaphor, the ultimate measure of what is possible, the universal speed limit, and simultaneously, a symbol of our innate desire to transcend the limitations imposed upon us by reality. Each photon that departs from a distant star carries within it not just energy, but a record of history, an echo of events long past. Traversing the void to reach our instruments and our awareness, it is a bridge across time and space, reminding us that our perception of the universe is both immediate and mediated, constrained by the very speed at which light travels. In this context, the pursuit of light speed is inseparable from the pursuit of knowledge. For understanding how light behaves is understanding how the universe communicates its own story. Across the decades, science has inched ever closer to approximating the conditions where relativistic effects dominate. Particle accelerators, from the earliest synchrotrons to the monumental Large Hadron Collider, serve as laboratories not only for discovering new particles, but for witnessing time dilation and mass increase firsthand. Observations of muons, whose fleeting lifetimes are extended when moving near sea, provide tangible proof that the universe enforces its laws with precise consistency. Atomic clocks flown on aircraft or satellites reveal measurable shifts in time, tiny yet undeniable, echoing Einstein's predictions and confirming that the passage of seconds is not absolute but relative, bound to velocity and position within space-time. Even in these controlled experiments, the subtle beauty of relativistic physics becomes apparent. The universe is not uniform in perception, and yet it is immutable in principle. Every test, every measurement, is both a technical feat and a meditation, a reminder that observation is an active dialogue with the cosmos. Technological initiatives, like NASA's plans for high-velocity interstellar probes or the Breakthrough Starshot project, reflect humanity's desire to take these insights beyond the laboratory. Tiny spacecraft, propelled by intense laser beams and equipped with photon sails, would traverse interstellar distances at fractions of light speed, opening the door to direct observation of nearby star systems. The engineering challenges are staggering, protecting delicate electronics from high-energy particles, generating sufficient thrust without mass penalties, and maintaining communication across light years. Yet these obstacles serve not to diminish ambition but to sharpen it, illustrating that every advance in science is also an advance in imagination. The attempt to approach light speed is therefore not just about motion. It is about confronting the edge of feasibility and discovering what is necessary to exist at that edge. At the same time, the pursuit of light speed forces reflection on human fragility. Near relativistic travel magnifies the universe's hazards. Interstellar hydrogen becomes a particle accelerator in miniature. Cosmic rays strike with energies capable of destroying molecular structures, and the relativistic blue shift amplifies background radiation to levels that challenge both materials and biology. Even the act of perceiving the universe at such velocities is altered. Starlight concentrates into bright arcs, and the cosmic microwave background transforms from a faint glow into an energetic torrent. Humanity, in its current form, is not equipped to survive these extremes, and yet the mind can simulate, predict, and explore these conditions through computation, modeling, and thought experiments. In contemplating such extremes, we learn not only about physics, but about the boundaries of survival, perception, and adaptation, and about the extraordinary measures required for life to extend beyond its cradle on Earth. Philosophically, light speed embodies tension between what is achievable and what is knowable. The impossibility of reaching C is not a failure. It is a defining principle that shapes the structure of reality. Were it possible to accelerate matter beyond light speed, causality would unravel, events could precede causes, histories could overlap, and time itself would fracture into incomprehensible multiplicities. The universe enforces this limit with elegant rigor, preserving coherence even while presenting an insurmountable frontier. In recognizing this, humanity confronts a paradox. The boundary we cannot cross defines the framework that allows thought, memory, and experience to exist at all. Constraints are not mere obstacles, but conditions for existence, and light speed stands as the ultimate example. The search for its meaning is therefore inseparable from the search for our own place within reality. Speculative theories, while remaining in the realm of imagination, illuminate the philosophical dimension of light speed. Concepts like the Alcubierre warp drive, which proposes bending space-time itself, or the hypothesized tachyons, particles that would always travel faster than light, push the mind to confront the consequences of transcending limits. Warp drives, if feasible, would not violate relativity locally, yet they demand exotic forms of matter and energy far beyond current understanding. Tachyons, on the other hand, challenge causality, suggesting that faster-than-light travel would necessarily distort the sequence of events. These ideas, whether physically realizable or not, force reflection on the relationship between possibility and principle. In exploring them, humans navigate the boundary between the universe as it is and the universe as it might be, using imagination as a guide through the architecture of law and limitation. In contemplating light speed, humans also confront temporality in a profound way. Time itself is malleable at relativistic velocities. Clocks slow, durations stretch, and experiences diverge from those left behind. A traveler near sea could witness lifetimes passing outside their vessel while their own journey remains brief, compressing epochs into subjective instants. This phenomenon is not merely theoretical. It has been observed repeatedly in particle physics, GPS technology, and high-altitude experiments. The implications extend beyond science into human perception. To approach light speed is to approach a different experience of reality, where duration, sequence, and consequence are transformed. In this sense, the pursuit of light speed becomes a meditation on the nature of experience itself, revealing that reality is inseparable from observation, and that consciousness is defined as much by the limits it cannot cross as by the horizons it can reach. The metaphorical resonance of light speed deepens when reflected against the human psyche. It is a pursuit that mirrors desire, the yearning to touch what cannot be touched, to surpass what cannot be surpassed, to see what cannot be seen. It represents aspiration, curiosity, and ambition in their purest forms, revealing that limits are not merely barriers, but catalysts for imagination and growth. In striving toward light speed, humanity confronts both the grandeur of the cosmos and its own impermanence, recognizing that while we may never achieve the velocity of photons, the very act of reaching, calculating, and envisioning is transformative. It is an engagement with possibility, an assertion of presence within a universe that is vast, indifferent, and magnificently ordered. Ultimately, light speed is both boundary and mirror, physical law and philosophical guide. It defines the structure of the universe and the limits of experience, reminding us that reality is constrained, coherent, and consistent, while also offering the freedom to imagine, explore, and reflect. Photons, traveling ceaselessly across the cosmos, embody what humans can never fully become: eternal motion without aging, witnessing without influence, traversing space without impediment. In aspiring to understand or approach their velocity, humanity confronts mortality, limitation, and the finite nature of its existence, yet also affirms curiosity, creativity, and consciousness itself. From Earth, the blue planet glows faintly against the dark canvas of space, its light streaming outward at sea, a signal of life, thought, and ambition. Every photon carries the story of billions of years, of oceans and mountains, of civilizations and dreams, traversing distances that human beings can only conceptualize. As we study, simulate, and dream of traveling at light speed, we recognize that we are part of this continuum, observers, participants, and storytellers in a universe bound by immutable principles, yet open to imagination. The pursuit is not merely technical, it is existential. It is a reflection of humanity's need to reach beyond itself, to touch the infinite through understanding, and to find meaning within the constraints that define the cosmos. To chase light is to chase comprehension, to stretch the intellect and the spirit toward the ultimate horizon of possibility. It is a pursuit of knowledge, of self-awareness, and of cosmic perspective. Though matter may never reach the speed at which photons travel, the mind can approach it, exploring the consequences, modeling the effects, and reflecting on the profound mysteries revealed along the way. In this pursuit, physics and philosophy merge. The immutable rules of the universe illuminate the contours of thought, imagination, and being, offering a pathway through which humans can engage with the sublime, even when they cannot occupy it physically. And so, light speed becomes a meditation, a story, and a mirror. It teaches humility in wonder, demonstrating that some boundaries are inviolable not to frustrate, but to define. It shows that curiosity and aspiration are as fundamental to existence as atoms and photons, that imagination can probe where matter cannot, and that understanding the laws of the universe is itself a form of transcendence. In this sense, the pursuit of light speed is inseparable from the pursuit of consciousness, knowledge, and meaning, a reminder that the cosmos is both a realm of immutable law and a canvas for human thought, a place where the ultimate journey is as much inward as outward, and where the light we chase illuminates not only the universe, but the depths of ourselves, humanity's relationship with light, speed, and the cosmos thus becomes a narrative of aspiration woven into the fabric of reality. While the dream of traveling at light speed may remain forever out of reach, the effort to understand it enriches civilization, deepens philosophy, and fuels the imagination. Every calculation, simulation, and reflection is a testament to the capacity to grapple with extremes, to conceptualize the unimaginable, and to find beauty and meaning in the pursuit itself. Light speed is not a destination, but a horizon, one that defines perspective, challenges perception, and inspires contemplation. In reaching for it, humans engage with the universe in the most profound way possible, with awe, respect, intellect, and wonder, inhabits a space between the finite and the infinite, a liminal zone where knowledge and wonder intersect. Each photon that leaves Earth carries more than energy, it carries meaning, a chronicle of life, thought, and curiosity. They are messengers of a civilization that measures time in decades, but aspires across millennia.